Good evening, gentlemen. I'm not done going through all of the combat code in VMS D&D yet, but it's obviously not using the same mechanics as White Box Dungeons and Dragons. That's kind of interesting. This must be something that Dan came up with on his own. It's very it's very complex compared to tabletop rules. But I guess that's the advantage of computers. You can have complex math without slowing the game down. Oh, but oh boy, what a big bunch of stuff. And those are actually comments in the code right there. These are some of the only comments in all of the source code, other than like this section is for the throne special feature, and then there's no comments in any of the rest of it. But yeah, these actually explain what's going on, which is pretty damn good. Because oh god, what a mess. Anyhow, I'd like to talk a little bit about the implementation plan for this thing. Um, I think that the first order of business, as far as re-implementing this game in a more portable language, with cleaner code, so that we can do something with it afterwards, is to make a like a work-alike. In C, I know some of you don't like C, but it's the most portable yet most low-level language that runs on the most old shit that I can think of, and I know it fairly well. I mean, we could use like fourth or something, but I don't know fourth. And I think the initial this initial work-alike should target 8-bit microcomputers with 640K of RAM. And I know. You're saying, well, Lee, these dungeons that the player explores. I mean, they're 8K. That's like you're going to run out of memory. Well, there's no reason, I think, to load the entire dungeon into RAM all at once, the way the existing versions do. The monsters don't move around. They get spawned in a place, and you run into them, and then you have combat. There's no simulation going on in the dungeon at all. Stuff doesn't go on in areas of the dungeon when the player's not there, and so it won't matter if we're not simulating lower levels and higher levels of the dungeon while the player's exploring the current one. So I don't think there's any reason to load more than one dungeon level at a time. And in fact, it may behoove us to kind of separate all of the dungeons out into a file per level. That'll kind of help us out a little bit later on, I think. But I'll talk more about that later. Because if you think about it, I mean, if each dungeon location is represented by a 20 by 20 grid of bytes, then that's 400 bytes for the whole dungeon level, and that's more than practical to fit into a 640K 8-bit micros memory map. Of course, we'll have to track monster locations and loot locations, but that's no big deal either. I'll probably see. Here's another thing. All right, another way that I think we could save memory on small computers. Well, I guess an IBM PC is small too, but there's a big difference between 640K and 64K. But look at this dungeon level. This is level 1 of Telengard right here. And dungeon special features, you can see that we've got a few here and there. They're actually, I think there are about 25 dungeon special features on this whole level. And there are 400 cells in the map. So, I mean, that's... And every one of these cells is wasting 4 bits to have nothing in it. So if there are only 25 special features in a dungeon level, I don't see why we can't just have a list of special features, like a number representing the type of the feature and then its X and Y location. And we can just walk through that list whenever we want to see what, if any, special feature is in the current location. I mean, sure, that's going to take more CPU time than, just looking up something in a two-dimensional array. But this is a role-playing game. It's not a fast-action game. And, it's 25 entries in this list. It's even on a 1 megahertz Apple II, it will take no time, basically, to walk through this list. So that'll save a lot of space. I was kind of thinking it's unfortunate that Dan chose to make the dungeon levels 20 by 20. If it were me, I would have probably made them 16 by 16. Because then we could have packed each of these special feature locations into 1 byte. But unfortunately, we'll have to use 5. We would have to use 5 bits each for the X and Y locations of these dungeon special features, which would technically give us, room for 32 by 32 dungeons. So maybe we could support that in the future. But the classical dungeons are all 20 by 20. So we'd have to use 5 bits for that. And assuming that each entry in this list was a 16-bit unsigned integer of some kind, that would leave us 6 bits left over for the type of dungeon special feature that it is. So that would technically allow us later on to extend the game with up to 64 different types of dungeon special feature, assuming there was room in the code segment for that. But we'll talk about that later too. But in the short term, let's see. So the thing is, though, if there are 25 dungeon special features, and we're packing these 3 data items into 2 bytes, we'll have to do a bunch of bitwise operations to extract those numbers from those 2 bytes. And if the code to do that itself takes more than 25 bytes, which it surely will, then we might as well just use 3 bytes to represent the type of special feature in its X and Y location, which would give us potential room in the future for dungeon levels of 256 by 256 and 256 different types of dungeon special feature, which, yeah, that would be faster too. We wouldn't have to do those bitwise operations on every element of the list every time we walked through it. So, yeah, I think we could optimize for space, but we'd end up losing it in code size, and so it'd be a wash. So we might as well just use 3 bytes for the dungeon special features. Yeah, so that would mean that a single dungeon level would be about 475 bytes, because we'd still have 8 bits for the walls of each cell, for the north and the west walls. So that would also give us room for 16 different types of walls instead of 4, extending the game in the future, which would be cool. And I think it would all still run okay on 64K 8-bit micros. Now, since yeah, okay. Right. So with the potential of 255 different special features, we could have special features that scattered flavor text throughout the dungeon, like describing these different rooms that you were in. That would add a lot of ambience to the game. But we can't fit a bunch of strings, a whole shitload of strings, into the memory space into the address space of an 8-bit micro. So we'll have to do something like the Iman Adventures did on the Apple II back in the day, and have all of the long strings. They used it for room and item descriptions and a bunch of other shit like that, but we can just use it for generalized long strings referenced by dungeon special features and shit. They can be stored on disk, and we can we can read them from disk into a cache that only holds a few of them, and sorts them by what was referenced last. So the stuff that gets used a whole lot, it doesn't hit the disk for every time, but like the stuff that only gets used every once in a while, it'll just do a little disk read right quick, and the game will pause for just a second while it reads the string off of the disk out of this random access file. But in practice in the Amon Adventures, it didn't negatively affect the gameplay like that, and they did that caching dealio in assembly language, even though the rest of the games were written in BASIC, so it wasn't slow either. So I think that would work. Now, when we're targeting small systems like that, though, we don't want to be dynamically allocating memory. We can't be using arbitrary length strings, but then on the other hand, we don't want to pad each string out to like 256 bytes or something, because that'll waste a shitload of memory. But let's see. So at 80 columns, 5 lines on the screen would be 400 bytes. No, that's way too much. So most long strings will be like half of a line at most. So we could store long strings as 64-byte blocks of text, and at the end of the block, for strings longer than 64 characters, there could be a pointer to the next block that's supposed to get appended to it, or like a 0 to indicate that there are no more blocks to be printed. And then we can just use a 64-byte structure, an array of 64-byte structures, to store that text string cache, and it'll be predictable within the memory map, so we won't have like stack heap collisions and shit. There won't be any dynamic allocation going on, taking up space on the heap. Okay, yeah, okay, that'll be good. All right. But anyway, I'm getting way off the reservation now. The initial implementation of this thing should be a work-alike, I think. Not trying to extend the game or anything like that, just a work-alike. And we'll target 64K 8-bit micros. And once that's done and working, which shouldn't be a terribly huge project. I mean, it'll be a little project, but it's an achievable goal that I haven't let spin out into like creeping featureism. That's the important thing. We don't want to be adding shit at this point and causing the project to never get done. A work-alike reimplementation targeting 64K 8-bit micros. 6502 and Z80 is what I'm thinking. But if somebody wanted to port it to something else, that would be cool. All right, so then once that's done and working, we can start to extend the game in the ways that I was just talking about. Still trying to target 64K 8-bit micros, but inevitably I am sure that there will come a point when shit becomes too fancy to run on 8-bit machines. And when that happens, we can do a code freeze and fork. All right? And the pre-fork version, we clean up, we make nice, we make feature complete for what it is, and that'll be version 1 of the game that runs on 8-bit micros, and it will not have any new features added to it, just bug fixing. And then that forked version, we will then target 16-bit micros, 512K 16-bit micros like the IBM PC and XT, or the Apple IIGS, or old Macintoshes. And you ask, like, why 512K instead of 640K if we're talking about old PCs? Well, we want it to run good on Tandy 1000s because that's my favorite kind of old PC, and they steal 32K of the system RAM for video memory. So you typically only have 576K available in DOS, and that's before you load device drivers and shit like that. So I think if we try to target 512K, it's a good round number. We make sure that our process size, or whatever you call it in DOS, doesn't exceed that, and we'll keep it within those constraints. And I think that's a realistic constraint going forward. I mean, obviously, with 512K, we can't simulate the entire game world all the time. But, 512K, in the context of something like this, is quite a bit of memory, and we can certainly simulate the dungeon level that the player is in, as well as all of the surrounding levels, the level above, the level below, so that monsters, move around and can go up and down stairs chasing you and shit like that. I think that would be a good thing to add. Monsters that have, not like super duper AI, but can like move around and do some stuff, you know what I'm saying? And the way the game currently works is, when you go up and down stairs and shit, it just takes you up and down a Z level. They link to the exact same XY location on the lower, higher dungeon level. But once we start extending all of these special features, we can probably add like a small data segment of some kind to each special features record in memory. And then we can link like maps together in more interesting ways. Like imagine instead of drawing dungeon walls with pound signs, we were drawing like colorized ASCII forests with asterisks and periods and commas and shit. And the levels closer to the road had the lower level monsters in them, but then you could go off the edge of the map in some direction and it would be like going down a dungeon level, or you could like climb up a tower, or just, much more interesting map interlinkages and shit, right? Right. So, yeah. And we should, when we get around to extending the game, we should take out the static, like, game-wide monster encounter tables and implement monster encounter tables per map. Because then we can make sensible monsters between the aforementioned forests, and we can have, like, themed dungeon levels and shit like that. I think that'd be really interesting, because what I want to do as we extend the game is to, like, go through here and, like, add kind of a story to each dungeon level that the player can like dive into as they explore. Not like a story per se, but like a theme. Like and like locked doors that take specific keys that you have to go find. Like a little more structured play and a lot of flavor text. You know what I'm saying? Like it can talk about like what's in these rooms and stuff like that, and have monsters, like boss monsters in certain areas and stuff like that. I think that'd be really cool. And then like as you beat each dungeon level, then you can descend down to the next one, and it'll be cool. I think it'll modernize D&D in the same way that Angband and NetHack modernized Rogue. You know what I'm saying? Because I guess since the source code wasn't available for many years, and when it was available, it was absolutely shitty and unreadable. I guess that's why this game never went anywhere. Quite frankly, I like the user interface way better than a typical roguelike. It's all context based. You don't have to remember like a huge, complicated key map. So like it's very accessible, way more accessible than traditional roguelikes, even though this is like earlier than Rogue, I guess. Anyway, I've blathered on, 20 minutes? Jesus Christ. Okay, so, yeah, if you're still watching, you are crazy. Adieu, crazy person.